Hello everyone, this is the solution video to Quiz2. Now, in the quiz, we are asked to write a function that generates a circle. We're given the position in integers, x and y, and we have a radius. And it goes like the following. We are going to place dots for blank pixels in order to see the coordinate system here. And then when it's going to be the inside of a circle, then we will place basically the plus sign here for the circle pixels. Now the screen is a width by width screen, and it should be a generic one, so we should be able to change the width of the screen. So yeah, and there are some restrictions on the functions. We cannot use printf, sprintf, or other lib functions. In fact, we can only use basically the malloc function from stdlib and the math lib square root function here, because only those two are necessary, and the other stuff, all the remaining stuff, will be coded in bare code. Now, the function should return a non-terminated string. I have provided you the template for that. So when we basically call this function here, it will give us a char pointer, a string, and we are going to printf it with %s, and we should be seeing the whole circle and the screen together. Now, for the sake of simplicity, we have width 10, but again, the width can change and it can be altered. So instead of using directly the number 10, what I'm basically trying to tell you is you just use width and code it like that. Now, there's also some important stuff going on here. If you are using Windows, it would be a good idea if on Mac or other Unix systems, I don't have them available right now, so I couldn't check, but I believe you should be able to manipulate the font of your terminal. But in Windows, I have provided you a screenshot here which shows you how to change the font of your basically terminal. If you don't do that, it would look like an ellipse, or it would not resemble a circle. Therefore, if you change that, you can just directly be sure of it. Now, I have also provided you some example screenshots here. Here we can see when the width is, for example, equal to 100. You can see that there are many pixels, and if you have more pixels, you have a better resolution, and you can see it is a circle. It starts at 0, 0, so the top left corner is 0, 0, and it has a radius of 50. So you can see it goes on the middle of the top section here, and on the middle of the left edge here. So of course it's not a restriction. I have provided you some screenshots, but it could be right in the middle. You can test it out. You can just change the position. For this one here, you might maybe try, I don't know, maybe like 40, 40, and then 40 would maybe be right in the middle on the screen here. Yeah. So, what I'm going to do, since there's square root, it involves a little bit math. What I'm going to do is I'm going to show you the templates that I've provided here. So first of all, we have this main function here. You can see I have tested two of them. We are going to printf it. So yeah. So what would be basically, the function looks like this. What would be basically the algorithm or the path that we should take here? Well, since when we look at the screen here, this width 10 example looks better, I need to somehow generate a string data, and I can see, since I'm using printf, at each end of my line here, I have a new line. So basically, even though this has width, I will have width plus one for my string. Since I'm creating a string, and I'm going to, I'm sorry, since I'm going to use malloc here, I'm going to have width times width pixels. So width times width will be the amount of pixels because that's the screen size. But for every width, I will have an extra kind of character, or pixel sort of, that represents the line break new line here. So therefore, in fact, for each width, I will have width times 1 more data. This would give me this here, or I could also write it down like width plus 1 times width, like this. So I have width rows and width plus 1 columns. And I will also have basically the null termination. So this would basically be the size that I'm going to allocate here. So therefore, let's write out a bat. Just use malloc here. So screen. I don't know why it didn't recognize it. Malloc, and then width plus 1 times width plus 1. So again, I have a width times width screen, but for every row I will have a new line, and I will also have the null termination, which is basically this one here. So why do we need the null termination? Well, basically, we provide a pointer to printf, and printf looks for the null termination to stop. So it starts from the address res, and it goes on in a while loop. You can think it like a while loop, and it stops when it reaches a null termination character here. Unless you have reached this, you will just printf each character. So therefore, we will provide a stop sign here. We need the new lines here, and we have a width times width here. So, what now? Well, what we can do is we can do the following. Let's basically have a for loop, int I equals 0, I less than width. Well, basically, width plus 1, I'm going to cycle through each pixel here, and I plus plus, like this, and then screen I, and then dot, and there we go. Now what I'm basically trying to do here is I'm trying to clear the screen. I'm basically generating the screen here. Let's compile. Let's run. There we go. Now, of course, this isn't right. We should have the right amount of pixels here, but we don't have new line. So when you don't draw a circle, the screen should be a square. Now, what is the problem behind this? Well, basically, the problem is the following. I said that at each end of the row, I will provide a new line, but here in the code, I didn't really do that. So how can we do that? Well, we need to check if we have, since we have 10 here, if we are at the 11th character, for example, this one here, that should be a new line. 22 should be a new line, 33 should be a new line, 44 should be a new line, and 55 should be a new line, etc., etc. And of course, you wouldn't have, you would actually have 66, 77, and then 88, 99 should be a new line, and then you are basically good to go. Of course, the last one should be a null termination here. So let's quickly fix that. Sometimes it works with null termination, sometimes it doesn't. So you should be sure of it. So what I'm going to do is I'm just going to take this last cell here, which is not included in the for loop, and put it in here and provide the null termination. So there we go. Now we have null termination, but we still didn't fix the row issue here. So I'm going to use the mod operator and check if I is a certain number. For example, if I mod since my row size is width plus 1, if this is 0, if it's divisible, then else. So, if that's not the case, I'm going to fill the screen with that. If that's the case, that should be a new line character. So width is basically 10, and we're taking the mod operation plus 1, so 11. So it should be basically 10. The remainder should be basically 10. And if that's, I mean, it should be 0 after 10. So the next one after 10. So you have 10 pixels. And then the next one would be mod 0. You have 10 more pixels, and then the next one would be 0, etc., etc. So if I compile, like that, you can see we sort of created our screen here. Now, this is the screen. Let's see, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 pixels. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 3, and 3, I guess. Do we have a new line there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If you resize the CMD window, you might be experiencing some problems. Just clear the screen once you have resized it and run it again. So we have a 10 by 10 screen now. Now, if I change the width, it should basically change. So let's decrease it, for example. Let's run it, and here we go. We have basically a 5 by 5 screen here. So let's roll back to 10. Now we have basically created our screen here. What now? Well, we need to use the XY coordinates here and also the radius, and then somehow replace the according pixels with a plus sign. So for that, I'm going to do the following. Now here I've used a for loop that is one-dimensional. It just goes through each element and sets it to a certain value. Now, for the next task where I'm going to replace it with the circle pixels, sort of, I'm going to use a nested for loops here. And the reason for that is I'm going to treat it as a two-dimensional data, so I will have some geometry to work with. So we have that. I'm going to place that. And then we will have J. They should also be width. Of course, we could have had width and height as the screen size and then do some stuff with it. But yeah, we are interested in a circle, so why not have a ratio of 1? So an aspect ratio of 1 is okay for us. So, what now? Well, the interesting thing is going to be the following. We first need to check if at the current position, if we are in the circle or not. So from geometry, we have the following equation here. Y minus b squared equals r squared. So that's kind of the thing that we are looking at here. So what I'm going to do is I'm going to just look for this and calculate that, because I have that. Here a and b is basically the position here, which is in our case I and j. I'm going to be looking at that, and we have the data rad, radius. The parameter was called rad. So, and we're going to check if this squared plus this squared, the square root of that, so we need a square root, and that's where we need the square root basically. If this is less than or equal to the radius, then we are inside or on the edge of a circle. Therefore, we can basically assume that this pixel, based on this condition, should be A+. So, but the problem here is the following. Keep in mind that I didn't even have some arguments that are floats, because my screen is kind of set up in a command window environment, therefore there are integers. So this, however, is not an integer, and if you do it like an integer, you will lose some precision here. And that precision may be important because you might mess up the shape of your geometric shape, basically. So what we need to do is we need a temporary float value, set it to 0, and calculate this. So how can I calculate that? Well, since I have the math library, I can use square root, and then x minus I times x minus I, and then plus y minus j, and y minus j, and the square root of that. So now the condition reads as following. Temp is less than or equal to radius. Now here I'm going to use a plus sign for the assignment. So that's basically the idea. But what should be the index of this? Now, if you remember the previous laboratory sessions in two-dimensional arrays, what we've done is we've used width times and then I plus j as an index. This was a certain formula that we've generated because you've also seen, before I implemented this new line, the rows were side by side. So with width times I, where I is the row index, I can kind of calculate at which beginning address I am. And then I have a certain offset, which is basically the column offset j. So width times I gives me the global offset, or the beginning address, and j is the local offset, where j is basically the column. So the ith row and jth column can be calculated like this. But there's a big but here. Our width is not equal to width. If we were on, if this screen array was a numerical array, then we would have had this exact thing going on here. So you might go ahead and decide to maybe create a screen integer array and then a character and then copy the data to that. That's also possible, but I like to keep it lean and clean. So basically I'm going to do it using this character array screen here. Now, therefore, I have to update, for example, my width, because it's width plus 1. Why? Because I have a new line. So basically, there's a hidden new line here, and when they're side by side, I'm offsetting 1 off. So basically, instead of using width, I have to use width plus 1. But then again, we still have an issue here, and I'm going to just run it first and then see how to fix it. Then there's this issue here. And you can see that there is something going on here. We are somehow overriding the new line here, because we have placed the new line. We have basically created our shape, our screen, but then somehow during this indexing here, we have assigned or updated or overridden basically the new line value here. Well, it is possible to get basically the position of a new line. So how can we fix that basically? Yeah, it's a bit of a struggle. So let me first show you maybe what the problem is. In order to do debugging, I'm going to just include stdio, but then I'm going to erase it because I'm not going to use it in the submission. But when you want to use printf, you need to basically provide this stdio and then just remove it back. So I'm interested in basically the index that I've generated here. Let's look at the index. Whilst I'm at it, maybe I should do %d comma %d, and then the index is basically this one here. So ij and index. So I comma j, and then maybe this whole thing here. So now you can see we have 0, 0 goes to 0. And this is what I'm talking about. This problem is the thing that causes us the misalignment here. So usually the power of 11, so 11, 22, 33, you can see that one is also replaced, and 44, 55, and that's basically it. Those are replaced. From then on, since we are not we're not satisfying this condition, you can see it didn't mess up the remaining 4 lines here. So, and the interesting thing here is to basically, if you look at this range here, 0 to 5, what we're going to do is we're basically going to fix this by, so let me just, for example, add 1 here. Now you can see, did we do it correctly? I guess. Compile it again. Then we're here. Why didn't we basically see the result here? Interesting. Yeah. I guess we still have the problem here. When we run it, we will see that this doesn't update here. Am I not compiling? Yeah, there we go, of course. Now, we can see now the indexes are shifted, but I can see that 1 up to 6 and then 12. I should not spot any power of 11 here, because I have shifted it by 1. It shouldn't be possible to get the power of 11 here. So when we apply this here, you can see the shape kind of comes up. Now, of course, we have provided a little offset here, 2 by 2 by 4. But let's change maybe the position here and the screen size. Let's think about that. So what would be the result if we have a 5 by 5 by 5? 1. First we need to compile. And then run. It doesn't fit at this point. So maybe drop down the radius a little bit. There we go. We can see we have our nice circle. Now we're kind of ready to test it out But instead, in order to do that, I'm going to basically, now you can see we can just get rid of this one here. We can get rid of this one here. So this is basically the code that we are looking at. So we have basically a pointer. We filled our pointer with width plus 1 times width plus 1. And the reason behind that was that our screen size, or the screen area, is basically width times width. But then we need a new line for each row and then a null termination. And once we've done that, we've just cycled through each basically pixel at this point, or character in our representation. And we've checked if it's a power of 11, if mod 11 is 0. If that's the case, we've placed a new line because we're end of our width, because width is 10. So if this is basically 20, then this would be 21. And the rest of it was replaced with a dot. We also added our null termination here. We've defined a float number here. And we are basically using a 2D cycle nested for loop here. And our condition was the geometric fact that if we have x minus I squared plus y minus j squared, the square root of that, if that's less than or equal to r, then we are inside of a circle. This is basically the condition that checks that. And then we have a width plus 1. This is because we have width plus 1 sort of columns. We have width and then an extra column there. So therefore we navigate it using this width plus 1 times I plus j. But we've seen that this can be overriding our width plus 1 here. Since we are using width plus 1 as a factor, what we did is we just offset it by 1. So yeah, that's basically what we've done here. A quick check would be just to look for basically 0, if the 0th pixel is basically, so let me just replace main here. If it's at 0, for example, let's compile, let's increase that. Since we have plus 1, it could be the fact that the first pixel might not be set up. So let's see. You can see that here, maybe that is an issue here. So if we have 0, 0, you can see this one here. Actually, it doesn't really matter. It comes up with that, so that's not an issue at all. So it has 4 as the radius. Now, you might think that this isn't correct or there's some problems here. But the problem here is not basically the fact that you miscoded it or your code is wrong. It could be the fact that, and it's most probably the fact that we are using integers here. And in order to test that, what we can do is we can just use an external terminal. Let me just quickly, what did we do with this? So let me quickly navigate to that. And then let me quickly navigate to that. So now I have my CMD screen here. If I hit main, you can see this is basically the result here. Now, let's go to main.c here. Let's open this one here. Let's comment this one out. There we go. Now we didn't change the screen width. Let me just quickly do that. Let's go to 100. And there we go. Now you can see we have a high resolution, but the whole thing doesn't fit the screen here. So in the PDF, I had this already there. We're going to the fonts, choose the font, the last font here, and then you can just check for a square font. You can see it's 8 by 8. It's some random thing here. Now you can see we have basically the aspect ratio 1, and it looks like basically this here. So that's basically the code that I've coded for this basically quiz. You can play around with it. Maybe let's have a 25 by 25 and then 20 maybe. Some offsetted thing here. You can see we have a nice circle and we've placed it basically on the screen, and all that is this is basically a string and nothing else. So actually throughout the course I'm mostly tempted to just write some more interactive command line tools or stuff like that with animation, with some keyboards, but the thing that stops me is basically the different operating systems, and since there's no common command window tool that I can use, I'm just stopping there because it will confuse you, or some of you might not test it out. So if there's what you can do basically is you can just erase this whole thing here and then redraw it, and you can basically use this to have some animation in your command line, and you can basically then use a for loop and get char maybe to move this circle around. It would be quite nice or cool, but yeah, different command lines. There's no basically universal command line, and the code would vary. So yeah, that's the reason why I am stopping to do that. So that's basically my solution here, and hope that this was helpful. See you in the next videos.